Hello and welcome to this video on Rust programming. Earlier we have seen integer and floating types and some operators. Now we will deal with characters and string. So the fundamental thing about data types is that at the base level there are four types: integers, floats, characters, and strings. Everything else is built on this. Okay? For example, you will say an array. An array is nothing but a collection of integers, floats, strings, and so on. So these are primitive types. So of importance that we understand our primitive types well. So a character is included in single quotes like C style syntax, and a string is in double quotes. For example, this heart icon or hello world and other strings are in double quotes. So characters, we will get into details with characters. These are valid Unicode scalar points. So I'll show you in a bit what does that mean, Unicode scalar points. And strings are UTF-8 encodable strings. UTF-8, for those who don't know programming at all or new to programming. So the initial character set standard which defined the characters used in a program was ASCII. ASCII character set has values from 0 to 255 because it is of 8-bit. Out of those, first 128 included most of the printable characters. Not most, all of the printable characters. That was 7-bit ASCII. Those were the standard types in the times of C. But ASCII character set cannot include all characters. So later Unicode standards were introduced. There were of two different types. One was fixed width type, another was variable width type. The fixed width type encoding uses something like UTF-16 or UTF-32, where the width is fixed. UTF-8 is variable encoding scheme. Maybe later on when we go into details, I'll show you all the deep down details of UTF-8 and UTF-16 and UTF-32. From a practical point of view, UTF-8 is of the highest value for us because most of internet talks UTF-8. So the problem with ASCII was that it cannot represent symbols of other languages, excluding English. It can only represent English. So a need was there to represent letters from other languages. That's why Unicode was introduced. So UTF-32, as you can imagine, is can accommodate all the symbols of all the languages. Similarly, UTF-8 can represent all the symbols of all the languages plus extra. Okay, you can have emojis and this, that nonsense, everything in UTF-8. So the strings are in double quotes. In Rust, there are two things. One is a string and another is a string slice. So what you see here is a string slice. For example, I can remove this lifetime and this would be a string slice. Okay, we will get into that, what is a string slice and what's a string and details and all that. So the string is in double quotes. Let's call them string rather than slice and all and get into those details. We will get into those. So for example, if I say hello Steve in double quotes, it's a string slice. And we can convert them by calling a toString function on that. Okay. Similarly, we can create a string by using the constructor string from and then passing the string here. It's not really a constructor in traditional sense of object-oriented programming. So similarly, I can invoke s.toString here because s is also a slice. Now printing is standard. Since it's a primitive type, it can be printed easily. You use simple brace opening and close. I printed C, love, S1, S2, S3, and so on. So let's get into a bit of complicated ones. So here I have declared a variable pangram, and the line is the quick brown fox jumps over the lazy dog. I print it. Then I iterate over these words in reverse. So to iterate, we use rev, and I split the string using white space. So the words will come out in reverse. Okay, so first dog will come out, then lazy, then over, and so on up to the. So we can print word by word. Then what we can do is we can collect these characters and put it inside a vector of characters. What is a vector is? Vector is a sequential memory area. Not necessarily, yeah, it is sequential memory area where the elements are put in. It's more like an array. So you can think of memory locations one after another where the characters will be put. So you take the characters out of pangram and you collect it, then you can sort it, and then you can deduplicate the characters from the vector array. Now you can create a new string and you iterate over this character array using a for loop, and then you push those characters, and at the end you can put a comma. It's not really needed. Okay, no, it is needed to print the characters. If you don't understand what is a for loop and all that, that's okay. Just bear with this. You wouldn't understand if you're new to programming what is a vector. Okay, so we will get into all this slowly. For now, bear with me, and I put this. And then we trim the last two characters, the empty space and comma. And this is the definition of the characters we want to trim, and then we trim the matches. And then finally we have the trim str, which will give us the characters used in the pangram, which will be A to Z. Now, if you're new to programming, the next concept would be complicated for you. So suppose we have a string, once upon a time, triple dot. We prevent its automatic dropping, all right? And then string has three parts to it. One is a pointer to it, another is length, and the third is the capacity, okay? So once we have this string, as you can see, there are 4 characters here, 5, 6, 7, 8, 9, 10, 11, 12, and then 7, 19. So we assert that the string story has length of 19, okay? Then we call an unsafe string function from raw parts, pointer, length, and capacity, okay? Once we build this, we can print the string. It will print the same string once upon a time. Okay, don't worry about what is unsafe, what is not safe, and all that. So as we will progress, we will understand this more and more. So we run this program here, and we do cargo build and do cargo run. So as you can see on the first line, we have A and love emoji printed. Then we have hello world, hello Shiv, hello viewer, hello world. And then the pangram, words in reverse, used characters, and once upon a time. So if you have followed till here, I will I will show you the documentation of char. So it is a Unicode scalar value. What does this mean is, you go here, you can click here. Does not take anywhere. This is the link. So it defines the Unicode character values. So there is a lot of things you can read here and understand it. It defines the glossary. If you want more details, you can go to home.unicode.org and you can read the technical quick start and everything. All right. So with this, you can understand what is internationalization and all that, what is Unicode. So you can go through all this documentation and figure out what Unicode is all about. So as I said, it is a Unicode scalar value, and the ranges are from 0 to 10 FFFF. Now, surrogate code points, you can read about surrogate code points here. A Unicode point in the range D800 to DFF. Okay, this is the surrogate endpoint, so it cannot be surrogate endpoint. So these will return a compilation error. Okay, so similarly, this will return none. Okay, it will cause a panic because you are using unwrap on that. So unwrap expects a valid value. And similarly, you can have undefined behavior here. Okay. So that's about character. You can read this documentation further in more detail. But since you are watching the video, I assume that you are not comfortable reading the documentation, because people who are comfortable reading the documentation most probably wouldn't watch my video. Right? That's the fun part of it. Don't worry, I'll show all this later on as well when we get into this. Now, strings are nothing but one more thing. This left side defines all the methods. We won't go through all the methods right now. Once we need them, I will show you. And eventually the cookbook videos will show the uses of these methods. Now, strings are UTF-8 encoded global string. Okay, so I've shown you the string from, push, str, and all that. Sparkle heart. Now, strings are always valid UTF-8. Okay, there are other types of strings like OS string and C string. Don't worry about that right now. So the important thing is here, right? So the Unicode UTF-8 is also represented as Unicode 8. Okay. Now here is an interesting thing here. Okay. Suppose there is hang on. Okay. Suppose there is an ASCII string hello. Okay. Then the first byte is always 104, and you can compare the first index as byte. But in case of emojis, the first byte is 240, which does not help us. Okay, that is one example. Now, this one of the interesting things which is written here is this paragraph. Okay, to understand this paragraph, we have to read this. Okay, suppose we have a string hello, so its length is 5. All right, and its size is 20 because a character array, in a character array, each will occupy 4 bytes because it's UTF-8. Now, suppose we have this non-ASCII string, 5 emojis, so length would be 40. Okay, and similarly, this would be 20. The question is, how should SI work? If you want to take the index out, and like many languages allow you indexing of strings, for example, Python allows you that, Java allows you, C++ also allow indexing. The question is, should you treat it as a byte or as a character? Okay. Now that's the problem. Okay. So getting the ith char is possible. Okay. So by char, you can invoke the chars function and then take the nth and then you pass the index. Okay. But when you use I, what will happen is the underlying data could be one character or slice of a vector. Okay. So since we are providing only one index, it makes sense that you return a Unicode character's address. Okay. Now, what you expect might not be the case. Okay. The reason is, in this case, when we invoked, we got 240, but you would expect an emoji. All right. And rather than a byte, you will expect an emoji. This is the problem with Unicode. That's why you cannot index string by usize. By usize means you cannot just put a number in brackets and get the letter, because it is not clear whether you want the character or you want the byte. It is not clear. Okay, but slicing would work. Okay, slicing would mean that You want string from certain range. That is the characters, not the bytes. Okay. Although it should accept byte indices and return &str, which is UTF-8 encoded. Okay. But note that in this case, you will have to invoke it as bytes if you want to use byte indices. Otherwise, it will return character. So the default behavior would be this one when you use indexes. Okay. So this is an important point to remember. All right. And rest of the things we will see later. There are many functions associated with strings. For example, these strings are applicable on string, and these are applicable on the string slice. But since string also implements this deref target is equal to str, so it gets these functions from the string slice for free. You can invoke these onto string slices as well, but you can't invoke these onto string slice. You can't invoke push str, which we have used. For example, over here, we have used push str. You can't invoke this on, for example, s. Okay. Let me show you quickly. So, for example, if you say s push underscore str, okay, and we give it a character, okay, and we save it, it should not work. Right. Got our compilation error. So you take no method named push str for the reference &str, so it wouldn't work. The Rust analyzer message is a bit buggy on Emacs. It does not work very nicely. On VS Code, it works very nicely. So maybe from henceforth, I will use VS Code to make the video. But for now, it's in Emacs. So with this, we come to the end of this video. We will study strings a bit more in maybe 1 or 2 videos. I will try to cover some important methods associated with the strings so that we can make use of those in our programs. And after that, we will move on to control flow and looping, that is if else and for loop, while loop, and those kind of things. So I hope you have found this video useful and informative. If so, please subscribe to the channel for more Rust videos, and there are other videos also. You can browse the channel for that. And do like the video and share it wherever you want. And the reason I ask this is that I want the video to reach as many people as possible. And that's how it's basically a compulsion for me to ask, because there is no other way on YouTube to make your video reach other people unless you are willing to spend your own money on sponsored videos or paid promotion. And I don't want to do a paid promotion for my videos. So please subscribe to the channel, share and like, and make use of the comment box where you can give me suggestions, and I'll chat with you on there. Okay, if you have more questions, you can ask me there. You can make demands to me that you want videos on certain topics, and I'll see if I can accommodate that, because certainly I don't know everything. For example, if you ask me to make videos on Java, I'll probably not be able to, because I don't know Java. So with this, we come to the end of video. Thanks a lot for watching. Happy programming.